So, hi everyone. Today's topic classification of force in biomechanics and physiotherapy. Welcome today to today's video on the classification of force. Force is one of the most important concepts in biomechanics, physiotherapy, sports science, and rehabilitation. Every movement in human body involves force acting initially and externally. In this video, we'll understand what is force, different classification of force, example from the human body, clinical importance in physiotherapy and sports rehab. So let's begin. What is force? Force is defined as push or pull that can change the state of motion of an object. In biomechanics, force influence movement, stability, joint loading, muscle actions. The SI unit of force is Newton, represented by the letter N. According to the Newton's second law, F is equal to ma, which means force equal mass multiplied by accelerations. What are the classification of force? Then coming to the classification of force, force are classified, can be classified in different ways. Today we'll discuss the major classification commonly used in biomechanics and physiotherapy. Initial and external force, that means internal and external force, contact and non-contact force, static and dynamic force, tensile, compressive, shear and torsional force, muscle force and gravitational force. What is mean by internal and external force? Internal force are produced inside the body. This means come from muscles, ligaments, tendons, joint structures, etc. Example, when biceps contracts during elbow flexion, it generates internal force. What means an external force? External force act on a body from outside source. Example, including gravity, ground reaction force, resistance bands, weights, and manual resistance from the therapist side. During squatting, gravity act as an external force, while quadriceps generate internal force. So, what is meant by contact and non-contact force? Contact force requires physical contact between the objects. Example: friction, manual therapy pressure, ground reaction force, and resistance training. When your foot touches the ground during walking, the ground pushes back with equal force. Non contact force, these force act on without physical contact. The best example is gravitational force. A gravity constantly pulls the body downwards and affects posture, balance, and movements. Static and dynamic force. The static force occurs when there is a force production without movement. Example, holding a dumbbell in one position, the muscle contracts isometrically, producing force but no joint involvements. Dynamic force occurs when movements happens. Lifting and lowering the dumbbells during biceps curls. Dynamic force are seen in walking, running, jumping, sports activities, etc. Types of mechanical force: compressive force, tensile force, uh, shear force, torsional force, etc. What is mean by compressive force? A compression or push structure together. Example, weight bearing through the knee joint during standing. A moderate compression strengthens the bone, but excessive compression may causes injury. A tensile force pulls structure apart. Example, stretching of a tendon and ligaments during the movement. Tensile stress is common in hamstring strain and ligament injuries. What is mean by shear force? Shear force occurs when forces act on a parallel in opposite direction. Yeah. Example, anterior shears to the knee during ACL injury mechanism. Excessive shear can damage cartilage and ligaments. A torsional force involves twisting injuries during sports. This type of force is commonly associated with spiral fractures. Muscle force and gravitational force. Muscle force generate force through contractions. Types of muscle force: isometric, concentric, and eccentric contraction. Eccentric contraction often produce high force and are important for rehabilitation. Gravitational force constantly act on the body. Physiotherapists use gravity during muscle tension, exercise progression, balance training, and functional rehabilitation. The clinical importance for this force are: understanding force classification is essential for physiotherapists because it helps in injury prevention, exercise prescription, rehabilitation planning, posture corrections, and sports performance enhancement. In this topic we learned definition of force, internal and external force, contact and non-contact force, static and dynamic force, compressive, tensile, and shear force with clinical relevance in physiotherapy. Understanding force is a fundamental biomechanic causes because every movement and exercise and rehabilitation technique depends on the proper force applications. Thank you.